Hey everyone, thanks for joining. I see quite a few like-minded people. You're interested in security. That's very good, because I think if we want to go to infinity and beyond, security shouldn't be a second-class citizen anymore, right? If we want to build future-aware systems, systems that are ready for the future, IT systems that are ready for the future, we as engineers, we as architects have to do our homework, that these systems are secure, that all these API endpoints we put on the internet, all these agentic workloads we put on the internet, that all these are secure. And there are quite a few things you can do quite easily, and this is what this talk will be mainly about. Now, the idea for this talk kind of has a bit of a history. For 3 years, I'm now managing director and CTO. I work for a German SME, and we build custom future-aware software for large enterprises, automotive, insurance, banking, right? And for all these clients, security is of utmost importance. And about 4 years ago, we've been hacked. Okay, we've been seriously hacked. Our Confluence server was on the internet. We thought it was patched. It wasn't. So the attacker was quite well known from the UK. I think he's in jail now, but that's not the issue. So he stole most of our Confluence content. He did a lateral movement towards a Git server and also our Subversion repository. So he was able to obtain quite a few files. Unfortunately, a few encrypted password vaults also. So we weren't sure about what can he do. He tried lateral movement towards the infrastructure of our clients. And I think that was his whole purpose. He didn't want to attack us. He wanted to attack our clients, right? He wants to attack BMW or maybe Allianz Insurance. So that was just right before Christmas. And yeah, we had to patch 400 systems. So that was a lot of work. So that was 10 days of really long hours for our teams and myself also. And fun fact, a week later, Log4Shell came and we had to do the same thing again. And since then, we have improved our security posture. We have introduced secure coding guidelines. We had to do our ISO certification, so that helped us quite a lot to really improve our secure coding policies and practices. And this will also be in this talk. Now, if I ask you, what's the third largest economy out there? Well, it's definitely not Germany or Sweden. Maybe it's India, but fun. Look at this here, it's cybercrime, okay? And they have loads of money. 9.5 trillion, so that's the American trillion, so that's billion. So this is serious amount of money. They're highly organized, right? They have a department for ransomware. They have a department for, I don't know, money laundering. They have a department for developing the exploits, and different departments, right? Maybe they even have a support department, I don't know. So they are organized and they want to attack us, right? And they definitely have bad intentions. So we really need to make sure that, you know, if you think these are really professional, we also have to be professional. Unfortunately, we're all humans, we're all engineers, and engineers make mistakes. And the following slides is not about blaming the engineers, it's more about maybe finger pointing on the development process that was maybe a bit off or maybe not in place. Don't know if you remember that one. That was 2014. For the older ones, I think you remember OpenSSL, very known SSL library, is part of many web servers out there. And they have a heartbeat mechanism. And the exploit was called Heartbleed. So you see from this picture here, it's really simple. You send it a string like potato and you tell it 6 letters. You send it another string, maybe bird, it's 4 letters and you get bird returned. Now the nifty attacker thought like, hey, what if I say hat, which is only 3 letters, and I say 500? Well, what did that lead to? 497 bytes out of the memory of that web server, okay? So classic buffer overflow. And in that memory, unfortunately, passwords, certificates, all the stuff you definitely do not want to expose as a web server. If you look at the code, and I dug it up, so that here is the diff of the patch to that file, and you see that there were only 4 lines added, okay? And what was missing? The correct bounce check, okay? So simple, they simply forgot to check the input. Does the string match to the length that has been part of the request? Okay? In Java, if you would have wanted to write an exploit, that would have been roughly 186 lines of code. Also, not that much code, okay? And you can now say, hey, why wasn't there a peer review? Established for a critical component like OpenSSL. Okay, it was 2014. It's quite some time ago, but still, we can learn something from that. If you develop critical software components, maybe have a mandatory peer review in place as part of the process. Could have been done. That one here, also quite fun. That was Apple's SSL bug named Go to Fail. Not that, it hasn't been in the press that much, but it led to possible man-in-the-middle attacks because this double line there, the double go to fail, basically led to this here. It always went to fail, so the crucial bit to actually verify the certificate of the connection has never been called. Okay, so you thought you had an SSL connection, but unfortunately man-in-the-middle could have been possible here. I have an international keyboard. Probably the developer had a thick finger, so Command D and Command S, right? S is safe, D is duplicate line. Maybe it was that. I would say a static analysis tool would have found that. But since it's been out in the wild in production, it wasn't found. That one here talked about Log4Shell, classic LDAP injection, basically, okay? I don't know if you're all in the Java world, but basically what could have been done, the attacker could have sent a specifically crafted string and tried that it got logged by Log4j as a logging library. And if you craft that one, you could lead or you could have the logging library remote load a class, and that class could have been a remote shell so that you could then access the server that logging statement would have been logged to. Now, what was wrong here? Maybe the requirements engineering, okay? I mean, you could ask, and I think that's a fair question, why on earth should a logging library be able to load code? I don't know, right? It should log stuff, maybe to a database, maybe to a file, maybe to some Redis server. Yeah, all fair. But why should it be able to remote load code? I don't see the point of that, okay? My most favorite one, who's driving an electric vehicle? Well, I do. I have a VW, Seat, VW, all these brands from VW, right? So that has been exposed at the Chaos Computer Club Congress. That's always in Germany, always at the end of the year. All these hackers meet there, white hat hackers. And they exposed that one here. So VW put out a system on the internet, and the purpose of the system was to collect charging behavior of the batteries of your car. So far, so good. But in addition to only collecting the battery information, it collected personal identifiable information. My name, my email address, the VIN, so the vehicle identification number, right? That is also a personal identifier information. So they collected loads of data. And via some endpoint, it was possible, so the data was then stored in a huge zip file. I think it was 9.5 terabyte of data somewhere on an S3 bucket. And they were able to download that data. And that led to this here, okay? This here, each dot is my car or your car or wherever. So Copenhagen is there at the bottom right, for example, or Stockholm, Oslo, Brussels, London, Amsterdam, Munich, Berlin. And they could trace for each and every one of these 600,000 cars to the meter precise, where did you go? Here you live, here you go to work, here you buy a grocery, there's your church, and maybe you go to the brothel or something, right? So really serious stuff, definitely not good, okay? They had really precise GPS coordinates. They should have meant to be truncated. Well, they forgot about that one. And then, well, they put the system online. So what was the error? If you look at these URLs, which library was it implemented in? We're the Java guys. What Java? Spring? Library? Which library? Yes, thank you. That is the Spring Actuator library, a very, very cool and useful library if you develop cloud-native applications. However, you shouldn't put that one on the internet, okay? It's an internal library. You can put on your Kubernetes cluster and you can do like administration stuff with that. And the mean guy is this one here. So they put the heap dump endpoint on the internet. Heap dump is like get a memory snapshot of that JVM running. Then you get a cool open source tool, which is part of JDK, one of them. You diagnose the heap dump, and well, they found a few static variables, and one of these static variables, unfortunately, they had a really powerful AWS secret key. So with that, they were able to access the infrastructure. They downloaded the S3 bucket, the files. Done, okay? Now I could say after Dieselgate, VW didn't have to lose anything anymore. It didn't really matter. But still, this is serious stuff. This is not so good, right? So GDPR gone bad. So I hope you see security matters in software engineering. Cyber threats are growing, okay? Software is the primary attack vector. Security is no longer optional. I mean, if you ask me, it wasn't like optional like the 10 years, but the last 10 years. But hey, if we want to go to infinity and beyond, then it can no longer be optional. Breaches cost millions in damages and reputation. For your clients, for your company, you know, the company you work for your employer. And there are quite a few regulations out there and compliance frameworks that demand accountability from us now. GDPR being one of them. DORA, NIS2, Resilience Act, Cyber Resilience Act, EU Act, AI Act that is coming now also, okay? So there are quite some regulations coming and they are good, okay? Yes, it means work for us, but they are really good. And also customers and its partners expect us to develop secure software by default. I haven't had one product owner tell me, hey, Leander, you write secure code, right? So this is always kind of an implicit thing, unfortunately. With security, it must be built into every stage of your software development lifecycle. It's not like you can, I don't know, during development, scan a few libraries and you think you're done. No, unfortunately, it's not that easy. And retrofitting security at a later stage into your software is very costly, okay? It's kind of a re-engineering of the system sometimes. Okay, so we need to make sure that it's up and running there. Oh, I forgot the time. Okay. Now, in the abstract, I told you something about ISO 20001, okay? So that is an international standard for information security management systems. Wow, that sounds awfully, right, theoretical, right, and policies and stuff. But it's a systemic approach to managing information security risks within your company, but also for all the projects you're doing internally, okay? Many organizations nowadays require and demand this certification for compliance, okay? So for us as a independent software boutique, without that certification, we couldn't work for certain industries, okay? So that's easy as that. There is a dedicated one which is called TISAX, which is for the automotive industry, which is kind of a clone of the ISO 20001, a bit more harsh in certain places. But it helps to build trust with your customers, with the regulators, with the stakeholders. Yes, you have to implement certain procedures within your company, but it really helps to manage those information security risks. So if you want to implement that, well, you have to do risk management and you have threat mitigation. You have to define certain security policies and you have to implement certain governance, let's say procedures. And you have to implement certain technical and so-called operational controls to protect the data. I'm going to show you a few of these controls in a minute. For us software engineers, it basically means we have to implement secure development practices. So these controls are in the so-called Annex 8, A8, where we have to make sure that our code and our dependencies and our deployment pipelines and our infrastructure, that these are secure. And ideally, we have to implement all of this via some form of pipelines so that it runs automatically, right? Because humans make mistakes, they forget things, so it's always good to automate these things that they always run. Now let's have a quick look at the ISO norm, okay? I promise I'm not going to bore you. So you see here, you have 37 organizational controls. This is basically what you have to do within your company. 8 controls concerning people, okay? This is about recruiting and how what you do for awareness and upskilling and all that stuff. Physical, this is usually concerning your offices and the hardware you work on, okay? And then it's technological, so that's 34. Now, let's have a quick look. Where is it? It's a bit small, huh? So, let's have a quick look. So, use of what do you do? A825, Secure Software Development Lifecycle. What does ISO norm say? It says rules for the secure software, for the secure development of software and systems shall be established and applied. Great. Now we know what we have to do. Application security requirements. Information security requirements shall be identified, specified, and approved when developing and acquiring applications. Pooh. So you see, it tells you what to do, unfortunately not how to do it. Okay? So this is up to you as a team, or it was up to us, to then come up with solutions, right? So, okay. I mean, it's the good thing and the bad thing. I mean, it's, yes, you have to do something, but you can be creative. Okay? All you have to do at the end, when you have the audit, well, you have to convince the auditor that the stuff you implemented, the stuff you came up with, that it's enough. If he's satisfied with what you implemented within your company, you have the certification. So this is what we did. So we sat down, I did a call in the company, I said like, hey, we have to do that, I need help. Where are the security-minded engineers, architects, who wants to help? Fortunately, there were quite a few colleagues, and we sat down and we said like, okay, given that cycle, software development lifecycle, requirements, design, development, testing, deployment, right? And then you go over it. Sometimes it's this DevOps 8. It doesn't really matter. You can do the DevOps 8 or that circle here. And then we sat down and said like, okay, what can we implement? Okay, we have to do training. We can come up with some secure development checklists maybe. Maybe we can come up with specifically crafted security user stories, for example. We can do threat modeling, whatever that is, I'm going to tell you. We could do security architecture reviews, code analysis, dependency analysis, dynamic security testing, penetration testing, vulnerability management, right? When it later goes into the operational phase, you can do like, runtime security checks. So there's a lot of technology out there. There are a lot of things you can really do. This is what we came up. Then we sat down and then we wrote something called the Secure Software Development Policy. So that is kind of mandatory. The auditor wants to see some form of document and he wants proof that everyone in the company has read that document. Okay, I think he wants 94% you need to achieve. And that document now describes what we do during requirements analysis, how do we collect and analyze the system security requirements, how do we harmonize the design and any changes with our security architecture, how do we apply secure coding practices, how do we develop and continuously run automated security tests, and how do we recognize and resolve potential security bugs during operations, right, once your system is running. So that's a Confluence page. Is not that long, okay? We want to make sure that everyone reads it, okay? So having a 30-page document is not a good idea. Keep it precise, keep it short, then you will have awareness. But the thing is, okay, and that's now my job, unfortunately, all these requirements apply to all our projects, okay? However, so either comply or explain, okay? That's the principle. If you have a good justification why you need to deviate from some of the principles, that's okay, but it needs to be documented and you need to have a proper justification why you deviate. So, simple one, you're only responsible for the development, not for operations, then obviously you can skip all the operational parts. That's kind of the easy part. And what we also have, we have a few recommendations on how to implement the requirements effectively. Because we have so many different clients, for us it's really difficult to kind of say you always have to use the following tool because each and every client usually has kind of a different opinion. So that makes it a little harder for us. So here are a few other principles, okay? Together with the customer, you need to take responsibility. It's about awareness and open communication. So as soon as someone finds a vulnerability or thinks there's an issue, tell us, let us talk about it. Implement security early. Take responsible for your open source components, right? It's not like, well, I'm using Spring Framework. Well, it's their responsibility. No, you build the system with Spring Framework, so it's your responsibility to keep track of the vulnerabilities of each and every open source component you're using. And yes, that's work. Think about the transitive hull, okay? That's a lot of dependencies. Right? Don't implement security through obscurity. Security needs to be implemented at different levels: application level, system level, network level, physical access level, multi-layered security. Keep security as simple as possible, okay? Don't make it complicated. Define something called a security architecture. Think about minimal access rights, okay? So Docker images that use root as the user is definitely not a good idea, and it's just such a low-hanging fruit to not do that, right? Have automated security tests as a gateway, and secure configuration by default. Yes, sometimes the default configurations are not so secure. I'm just saying Spring Actuator, okay? So that thing is definitely not so secure because it binds the actuator endpoint on the default HTTP port. They even tell you in the documentation that you shouldn't do that, but the default configuration is still insecure, okay? Now, let's start with the early phase. So when's the right time for threat analysis? So for all the Star Wars fans here, I would say, back at that movie here, just before the Death Star blew up the first time, I think that was a little late, okay? So, sir, we've analyzed the attack pattern and there is a danger. 5 minutes later, okay? Unfortunately, more than 50% of all threats are rooted in the specification and the design. Now, the crux with specification and design is automatic scanning, static code analysis or something is not really possible here, okay? So it's really difficult to find automatically. So we need another approach. We need a more explorative method that can be used to identify the threats really early at the design stage, okay? And that is called threat modeling. So threat modeling, have a look at here. They have a nice manifesto to do threat modeling, but it can be fun. It's an agile method, okay? You sit together at the table and you ask yourself 4 questions. What are we working on? What can possibly go wrong? What are we going to do about it? And then you ask yourself, did we do a good enough job or should we reiterate and do it again, okay? So it's a really collaborative method. A really, let's say, well-established approach is called STRIDE. So STRIDE is an acronym for 6 attack patterns. So it's spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So what we're doing with these 6 possible attacks, we do whiteboard hacking, okay? For each one of these, we think like, okay, how could we spoof or how could we tamper with the system to gain access to the system? So to give you a few examples, spoofing was this here, okay? So when Chewbacca, when they tried to free the princess out of the jail at Star Wars, okay? So the 2 Star Troopers, the 2 white guys, this was Han Solo and Luke Skywalker. So they spoofed, they feigned their identity, okay? In reality, so what you try to do is as an attacker, you try to impersonate as a legitimate user or as a device or as another microservice, for example, okay? Phishing emails is a form of spoofing, okay? The phishing email that looks like it was sent by your boss, where they say like, hey, please press the button or please send €500 to this account because I just bought something, okay? Spoofing, DNS or IP address spoofing, so that you can intercept traffic that is maybe not meant for you, okay? Tampering, so here when Obi-Wan tried to tamper with the tractor beam so that they could flee afterwards with the Millennium Falcon. So that was a proper tampering attack. So the attacker tries to alter data as it either moves between 2 points, so that is in transit, man in the middle, or while it is stored at rest. So maybe you want to tamper with a configuration file to turn off some access logging maybe, so that you that no one knows that you were there, okay? So that's tampering. Repudiation, so identity denial, or so what you try to do here is, well, you tamper usually with the system to maybe turn off some access logging, or you make the logging poor, or you disable some audit logs, so that no one can say like it was you, okay? So you can say no, that wasn't me, okay? Prove it. No proof there. Information disclosure, that's what happened to us with our Confluence server, okay? So that's the bad guy. This is what you definitely don't want to happen. So the attacker gains access to private and protected information, okay? So revealing error messages, for example, right? So you all know these pages, right? Where you probably sometimes have like a proper Java stack trace or something. Usually within these stack traces, there's, well, you know, information you do not want to expose on the net, right? Maybe some IP addresses or maybe some file paths or something. So reading private files, anything like that. Denial of service, okay, well, the attacker simply overwhelms the system with traffic and sends malicious requests, mainly causing your application to crash or maybe to become unresponsive, okay? So DDoS flooding attacks and resource exhaustion are usually done here. And last but not least, you have elevation of privilege. So what you try to do here is you try to gain capabilities without proper authorization. Okay, so you can do that in two ways, either vertical or horizontal. Vertical is you are a normal user and you try to become root, so that's vertical. And horizontal is you've logged into the system, and maybe you see, sometimes you see as a URL parameter for you, sometimes maybe an ID, a user ID. Well, what happens if I change the user ID? Can I then see the data of the other user? Okay, so that would be horizontal. And then obviously you think about the consequences, okay? Does the system blow up? In this case, does the Death Star blow up? So what you do here is usually have some form of diagrams, usually some form of data flow diagrams, and then you evaluate based on the diagrams what can be done. You see that certain attacks are not possible for each and every one. So spoofing, for example, is mainly done against processes and interactors. Or tampering is mainly for data flows and data stores and processes. So this is what you have to do. And then once you've identified these threats, you can define countermeasures. Ideally, you try to avoid it, okay? Maybe delete the feature or change the architecture. Maybe do some form of mitigation to complicate, to make it harder to exploit that threat. Well, yes, you can transfer the responsibility to someone else. If you are not responsible for the infrastructure, but you identified a threat in the infrastructure, then obviously you have to talk to the infrastructure team and say like, hey guys, maybe your firewall configuration should be a bit hardened. And yes, sometimes you have to accept things, mostly out of a cost-benefit consideration. Not ideal, I know, but sometimes that's the sad truth. Okay, so Stride as a structured approach can be fun. What we did, I mean, we all know we live in agentic times, okay? What we did, for example, to try that, we had a data flow diagram in plant UML. We gave that to an LLM and then used the LLM to discuss with us the possible attacks. So we told it, hey, given that diagram, tell me what you think, what you come up with for spoofing, okay? The results were not always correct, but it gave you a good idea and a good clue to get started. And then you say like, oh no, that's totally made up, that's not possible. But it was definitely a good approach to get this Stride analysis done quite quickly, okay? So be creative here. That can be kind of done with the help of an LLM at least, okay? Don't trust it 100%, okay? Okay, let's talk about security architecture. When I grew up as a software engineer, and that's quite a long time now, I think I studied computer science back in, finished 2000, okay, so I'm out there for quite some time. I learned software architecture in these three views: conceptual, technical, infrastructure. Conceptual is more about the data models, the use cases, the functional requirements, okay? So this is kind of the business architecture, let's say. The technical one is then, how do you go to implement the system technically, right? Do you do layers and onions, and do you use Spring or Quarkus, or which open source components do you use? What non-functional requirements do you have? Are there any enterprise standards or reference architectures I have to adhere to? And then obviously infrastructure, also important, right? Our systems needs to run somewhere. So again, here you might have some standards and non-functional requirements. You mainly have as outputs, okay, what type of hardware am I going to use? Which cloud provider? Is it EC2? Is it managed Kubernetes? What kind of databases do I have? How do I segment the network maybe? What software infrastructure do I have? Maybe you have an app server. Is it Postgres or is it Oracle? You know, all these things. Now, the job we have to do now is to secure these three layers. Okay, and this is what I call a security architecture. So given your security requirements, your security targets, everything that came out of your Stride analysis, and maybe some additional sources like OWASP Top 10, maybe GDPR, maybe the ISO requirements, maybe DORA, maybe NIST 2, maybe whatever there is an regulatory framework you have to also implement. Okay, all these are requirements towards your architecture, to all these three layers, okay? And then you need to well, be creative and come up with how do I secure the infrastructure, what do I do to secure the technical architecture, and what do I do to secure the conceptual architecture. Now, we're software engineers and we love components, right? Now, in this diagram, okay, think of a component like a conceptual idea, okay? So a component can be a data center. A component can be a virtual machine. A component can be a microservice. It can be a database. Yes, it can also be a software module, okay? Components are connected via a communication channel. They exchange data. There is data flow between these components. And also what you can do is you can define, is this, well, does the component need to be secure, very secure, or is it insecure? And how do I have to secure the communication channel? And how secure does the channel have to be? The red bit here is something I call gatekeeper. I didn't come up with a better name, but basically what you have to do is everything that goes out of the component you have to secure, and everything that goes into the other component you also have to secure. And then when you build systems, obviously components are meant to be composed, right? So you compose your system, and then you can have like form security groups. So maybe component D and B, well, you don't need any security at all. So it's the green gatekeeper between B and C, because maybe that's a different team. You say like, oh yeah, we need to implement some better security, and component A is super untrusted somewhere on the internet. You really need hard security here. If we double-click on one of those components, then there's quite some work to do, okay? So the internal design of a really trusted component is kind of, you have to do quite a few things. Given every data is untrusted, okay, comes from the outside, you first need to canonicalize and normalize the data. So basically you simplify the representation, either lossy or lossless. Then you need to sanitize the stuff, okay? Remove any nonsensical and harmful data. So that prevents pretty much every injection attack, SQL injection, LDAP injection, LLM prompt injection, for example, right? Also an injection form that will become very relevant, I guess, in the next years. And then you need to validate the data, okay? Think about Heartbleed, okay? If you expect 13 characters, then please validate that the string is 13 characters and not more or less, okay? Don't forget output sanitization, okay? So logging the full password, clear text password in your create user component is maybe not such a good idea, okay? So everything that you want to send out, please sanitize it somehow, okay? Maybe anonymize it, or maybe, you know, scramble it. Come up with something. I'm sure you heard of domain-driven design. And my most favorite, let's say, design pattern of this one is the so-called value object, okay? Think of an ISBN. Think of you build a REST service that accepts an ISBN string as a parameter. So is it a string from your REST controller back to the database? Or is it like actually a data type? And I would say it's a data type. And value object is a mean to model data types, okay? So these values and data types are usually immutable. Okay, once you construct these data types, you do sanitization, you do validation. If it's not an ISBN, then throw an exception or do something else. Okay, this is then not a valid data type. And then pass that data type from the REST controller down to the database. And then store it, okay? But it's not a string. If you do that, refactoring is, so this is also super refactoring friendly and refactoring safe. Aggregates, facades, so there are quite a few other well-known design patterns from this good old book here from the Gang of Four, right? So there is some value in these good old patterns and things established out there. I'm not going to read all this. Main point of this slide is clean code and clean architecture. If you have that, if you implement that, this is definitely more secure by default, okay? Because it's readable, it's maintainable, everyone can understand it, okay? It's well structured, it's simple, it's not complex, okay? So please try to write clean code and clean architecture. Now I've prepared a small repository for you. This is just to demonstrate that there are so many low-hanging fruits you can do to implement security during development. I've uploaded the slides to Speaker Deck, okay, so you can take a picture, but I've uploaded them. So, so this is the README file of that repository. I hope it's big enough. this is just a few ideas, okay? So this is a simple Quarkus application. Yes, it's Java, but the principles apply. Anyone heard of Google Error Prone? It's a mean thing, okay? It will break your Java compiler if you write unsecure code, okay? This will be really annoying, okay? But it will break Java compiler, so you can't even really commit this stuff, or you shouldn't commit this stuff, okay? Catches some stuff, okay? Have some form of static analysis, okay? Can be Sonar, there are other tools out there, but please do static code analysis, yes? Yes, also in times of agentic software development, okay? Static code analysis is your friend. If you don't have that, I would say this is negligent in 2025 and from now on, okay? And if someone can prove you negligent, no insurance will pay, okay? So be that as a warning. So have that. Fun fact, try that out. I've even implemented an MCP server for Sonar, so I can tell my agentic AI now, hey, get all the security issues for this repository and do a fix for them, okay? So be smart. Do some Docker image vulnerability scanning, base image scanning, loads of tools out there, Trivi, Sneak, Dockerfile lint. If you have Kubernetes, right, there are other tools out there. Scan your YAML artifacts for certain, let's say, configuration bad practices. Checkov, Sneak again, kubeconform, many out there, okay? Terraform, if you have, as an infrastructure as code tooling. Use that, again, Checkov, TF-lint, Sneak, again here, you will find quite a few security misconfigurations really easy, okay? Statically, as early as possible. That's the point. Then implement everything to have a continuous developer experience. Maybe use something like pre-commit, okay? Run some of these tools as part of your tool chain as part of the commit, okay? And if any of these tools fail, the commit will fail, okay? So that way you can make sure that no bad code, no insecure code will ever be part of your Git repository. Have some form of continuous integration established, okay? Also important, and yes, maybe use AI to help you with maybe some security checks, okay? Yes, we all know AI can produce insecure code, but on the other hand, you can use AI to kind of find the insecure code also. So I tried that. So security recommendations. So all I said here, for example, is, well, I said, hey, review all relevant files for any security issues and vulnerabilities. And then he said like, ooh, hard-coded password is not so cool. Overly permissive security group. So he also understands about Terraform, right? So it's really great. He found pretty much everything that all these static tools would have found also. But combine both, okay? I wouldn't have that here to just replace everything. Okay, then have some pipelines, okay? Please, CI/CD pipelines is an anti-pattern. This should be two pipelines in the first place. And then I think we need a different approach where to implement security. Why? Because in complex systems, pipelines only run when something changes. But what if a downstream dependency changes and introduces the weakness and the vulnerability, right? So I need some form of another approach to run security tests dynamically, continuously. Whenever something changes, you want tests to run. Now, if you say, hey, Leander, microservices so 2020, we don't do microservices anymore. Well, here's the agent version of that one. Doesn't really matter, okay? Agent A, agent B, MCP server, same thing, okay? They communicate, there are channels, this is components. Same here, models change, run the tests. Agent change, run the test. MCP server change, run the tests. Backend system changes, run the tests, okay? So if you have only one pipeline, I say you can do so, but it will suck in the long run. Here's my approach, how I would do it, okay? So that is kind of a secure delivery pipeline architecture. Have like early stuff during your CI phase, unit tests, maybe early integration tests, quality gates, then push your Docker images, have that check in the registry, have some form of GitOps, okay? No one should fiddle with the infrastructure, okay? Have this automated, all the deployment. Have some stuff run on a Kubernetes cluster in that case, maybe for some runtime security, maybe some policy engines here. And then you could use a tool like TestCube, for example, so that's that logo here, to then continuously run, for example, ZAP tests. open source tool, really easy to do like really simple OWASP top 10 based penetration tests, okay? And then what you need to have is a quality cockpit, okay? Where you accumulate all these findings, and then you have to make a nice fancy dashboard, and if the dashboard is green, then you're safe to release, okay? You can build that with Grafana and maybe InfluxDB yourself. I've only found one tool. Unfortunately, this is a commercial one, so I'm not going to show the slide too long. For open source, it's for free, okay? What they do is really cool. Along the software development lifecycle, they have integrations for all these different scanners, and they give you the accumulated view of all what your security posture is like, okay? So have some form of dashboard. Last but not least, implement a review process. I can recommend OWASP SAMM to continuously measure and improve your security maturity, okay? So continuously assess that one. So this is what the structure look like. I would suggest tailor it, start small, okay? So assess your current security maturity, then define security goals, realistic goals, start small, seriously. Introduce that within the next sprint or maybe the next release, implement the enhancement, improve the policies, the coding standards, the test automation, automate everything, then measure and integrate, and then you start all over again. This is what our teams are now doing. I kind of review on a quarterly basis now to see that they are doing something. I'm not interested in how they implemented it. I just want to see that it's implemented, and then there's something done. And then I guess you continuously improve, okay? So it's a journey, start small, track the progress, and improve. Last slide. So I hope you're convinced that security is not a second-class citizen anymore. Yes, I know it's one of many quality attributes, okay? Efficiency is important, functional suitability important, usability is important. Yeah, they're all important, but security is also important, okay? It's not a second-class citizen anymore, and you need to start from day one. You need to start really early to make your systems as secure as possible. Thank you.